automation will make healthcare more efficient and less prone to error. Today, machine learning is already being used to diagnose diabetic retinopathy and improve radiology accuracy. Someday, an AI assistant will assist a doctor in working through a complicated differential diagnosis. Our hospitals look roughly the same today as they did 10 years ago, because getting new technology into the hands of doctors and nurses is a slow process. Just ask anyone who has tried to sell software in the healthcare space. But technological advancement in healthcare is inevitable. Cosima Gretton is a medical doctor and a product manager with KariusDX, a company that is building a diagnostic tool for infectious diseases. She writes about the future of healthcare, exploring the ways that workflows will change and how human biases could impact the diagnostic process, even in the presence of sophisticated AI. I enjoyed this conversation with Cosima, and I am still looking to do more shows about healthcare and the intersection of health and technology. So if you've got ideas, please send me an email, jeff@softwareengineeringdaily.com. Spring is a season of growth and change. Have you been thinking you'd be happier at a new job? If you're dreaming about a new job and have been waiting for the right time to make a move, go to hired.com/sedaily today. Hired makes finding work enjoyable. Hired uses an algorithmic job matching tool in combination with a talent advocate who will walk you through the process of finding a better job. Maybe you want more flexible hours, or more money, or remote work. Maybe you want to work at Zillow, or Squarespace, or Postmates, or some of the other top technology companies that are desperately looking for engineers on Hired. You and your skills are in high demand. You listen to a software engineering podcast in your spare time, so you're clearly passionate about technology. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $600 signing bonus from Hired when you find that great job that gives you the respect and the salary that you deserve as a talented engineer. I love Hired because it puts you in charge. Go to hired.com/sedaily, and thanks to Hired for being a continued long-running sponsor of Software Engineering Daily. Cosima Gretton is a medical doctor and a product manager with KariusDX. Cosima, welcome to Software Engineering Daily.
Hi, Jeff. Thanks very much for having me.
Today we're talking about some various applications of machine learning or artificial intelligence in healthcare, which you have written about some online. What are the low-hanging fruit opportunities for AI to positively impact healthcare?
Yeah, I think that's an interesting question because healthcare is so broad and heterogeneous that I think the low-hanging fruit arise at the intersection of where machine learning is particularly good and humans are particularly bad. And I think that particular intersection, at the moment, we're seeing companies arise in that space of image recognition. So machine learning is applied to radiology, pathology, any task in clinical medicine where a human has to detect an anomaly in a very complex image. I was speaking to a company called Analytic a couple of years ago, actually, and they were talking about how, a single radiologist can spend 3 months learning, 6 or so features on a scan of a lung that helps them detect lung cancer, whether there's kind of slight speculation or a cloudy little shape. But obviously, a machine learning algorithm can learn 200 features in a matter of milliseconds. And so the speed and performance of machine learning algorithms over humans, I think, is a huge advantage in that particular vertical of healthcare.
Yeah, I was at a conference at Google. This is a TensorFlow conference, and one of the main presentations that people were really excited about was, you might have seen this diabetic retinopathy thing where they just did this huge study of how do doctors perform when identifying patients with diabetic retinopathy versus how the machine learning model performs. And the machine learning model was just straight up better over a large data set.
Yeah. And I think that's, to be expected. We are, historically there's been a lot of studies in human perception that go back many, many years looking at human perception in air traffic control situations or human perception in scanning of baggage. We have multiple different issues with the way we perceive things, where we have change blindness, we have issues with visual search and attention, and environmental factors and stress can exacerbate that. So I think there's a huge advantage with these systems. I don't believe it will remove the functions of the people who did those roles before. It'll just change their roles in the future, because there's we've seen this in medicine already. The more technology you bring in, you need people to manage it, and then their roles evolve into new areas.
Yeah. Well, we'll save that conversation for a little bit later if we get to it. I know you've written about the dire conditions that some hospital workers are enduring, and it's kind of like, it seems like automation could really help out. It's not like people are going to lose jobs. We've got more work than we can do today. But okay, so image recognition stuff is the low-hanging fruit. What are the big, ambitious opportunities that seem crazy today, but in 10 to 20 year time horizon are actually plausible?
Yeah, I think that there are two areas here, which is, I think the main one is diagnosis and being able to capture kind of, the full medical ontology to make predictions and diagnoses of a patient's particular condition. And I think that those are challenging from a number of aspects and very exciting. So, a lot of people, there's a lot of hubris around this field, and they talk about how you could predict someone who's going to have heart failure in the next 6 months, or, determine who is going to be more likely to have a readmission. Now, we have algorithms, models that can do that based on very highly cleaned and trained data sets. However, the practicalities of implementing those into clinical practice, I think, are what is going to make that very challenging. And I think those come in multiple different buckets. So one big challenge for applying machine learning in a diagnostic capacity, and I'm not talking about kind of diagnosing from an image, I'm talking about what happens when, a patient comes in the door and they have multiple different symptoms, they look a certain way, they have certain bloods, they have a patient history that's written in text. There's so many different sources of data that come in that a doctor is absorbing because we have multisensory perception. So we can not only read and listen, but we can touch and feel, the temperature of the patient. Are they clammy? Are they sweaty? And so being able to capture all of that currently with the systems and the technologies that we have is going to take a very, very, very long time to be able to get that full 360-degree perspective on a patient. And until you have that 360-degree perspective, being able to satisfactorily, reliably diagnose someone, out of all the potential medical conditions that there are, I think is going to be very challenging. The other factor is, I tend to think about when you take machine learning algorithms in diagnosis, is it diagnosing or is it predicting? And also, is it a novel finding or is it along the lines of an existing protocol? And so I think that there are also challenges in that space. So one of the issues with diagnosing versus predicting whether something's going to happen is that it's all very well to say, okay, this particular model can predict that someone's going to have heart failure in 6 months' time. But when you bring that into clinical practice, there are no guidelines and there are no protocols as to what the hell you do when someone doesn't have heart failure now, but is going to in 6 months' time. There's guidelines to say if someone's, legs start to get puffy, as happens in heart failure, okay, well, you need to increase a certain heart failure medication to reduce that swelling. But if that's going to happen in 6 months from now, what do you do to that medication? If you increase it now, their blood pressure is going to drop. And so, we did the medical science around the treatment and the intervention in advance, is still not there yet. Preventative care is relatively limited. So, and then there's the other issue around, is it a novel diagnosis or prediction or association, or is it one that's already written in the protocols? And I think that's also has a big impact on the level to which we'll be able to engender trust in these devices and these technologies amongst physicians. Because if a model is, making a diagnosis or a prediction that is quite within the realms of kind of general practice of medicine, that someone can corroborate with their experience, and they can look at the patient and say, yeah, okay, that model has said that. That kind of makes sense, and I might not have spotted it, but it's helping me. That's fine. If it's making very new associations that the doctor doesn't understand or medical science hasn't yet discovered, that's really exciting, but that's a lot harder to get into clinical practice and will take many, many, many more years. So people tend to lump, machine learning and healthcare into this one kind of gigantic bucket, and there's just so many different angles and verticals to it. So picking that apart will be really exciting over the next kind of, 10 years or so.
I have a quote from you. Well-designed, integrated, and intelligent software may go a long way towards reducing deaths due to medical error, but new kinds of errors will arise. Experts using technology are subject to all sorts of cognitive and decision-making biases that also need to be taken into account. End quote. So you mentioned a moment ago that the current day diagnosis is often skewed by bias, and that's why there's one reason why image recognition machine learning model for identifying a tumor or diabetic retinopathy is really useful, because you're not overly skewed by the biases of a single individual who's been diagnosing diabetic retinopathy for a decade. You have a giant data set of diabetic retinopathy and non-diabetic retinopathy things that might look like diabetic retinopathy that give you a large labeled data set that incorporates all biases and subjectivity that you could potentially factor into a large data set of images. But here you're saying that even if we have this kind of stuff, this machine learning, this model-driven diagnosis and perhaps treatment, even in this scenario, humans are still going to be involved, and there's still going to be cognitive and decision-making biases that are going to arise. What are you talking about here? Explain what these new biases are.
Yeah, so I think that the first thing to clarify is that humans will still be involved. I don't agree with certain perspectives around full automation of doctors. I think when you look at if you look at shopping or supermarkets that have automated checkouts, because you're dealing with a world where there's people involved in shopping and these automated checkouts, you need to have someone to deal with them when they mess up. People are messy, and so there will still be, even if you automate kind of 99% of medicine, there'll still be human operators. So what I mean then is that when you have a human operator operating one of these systems, is that, I guess it depends on the performance of the system. So there are different areas that arise, but I would imagine most systems would not have performance characteristics, that are perfect. There are obviously going to be, when you apply it into clinical practice, issues, moments where the system fails. And one of the things about automation that's been extensively studied is something called automation bias. So automation bias is when you have a human operator that is using an automated system, and they tend to slip into what's called commission and omission bias. So they will tend to do the thing that the system recommends. The commission bias is when they'll do the thing that the system recommends, even if the thing is wrong. And then omission bias is where they won't do the thing because the system didn't recommend it, even when they perhaps should have. So it's about complacency, and it's about over-reliance on the system, over-reliance for the system to detect things, and if it hasn't detected it, the assumption that it wasn't there. And so, if these systems aren't 100% perfect, which they won't be, there is going to be a gap where the systems fail to perform and the user over-relies upon them. So you can see it very clearly in things like aviation. So if you look at the 2009 crash, the Air France crash, the pilot relied overly heavily, it was the one that was going Paris to Brazil, I think, on the automated system. And when that failed, was unable to, manage the plane. And so I think that's one aspect, is automation bias when the system fails. The other one is around the fact that when you speak of healthcare, you don't just speak of a patient, a doctor, and a machine. You also talk about the multidisciplinary team that is around it. And so, humans have a certain trust amongst each other as to their professional expertise, and equally they have trust, to machines as in terms of their ability to have a certain performance. And if a machine makes a certain diagnosis, that diagnosis then propagates amongst the team. And so the team then spreads that diagnosis amongst the physiotherapists or the primary care practitioner or the nurses. And you get something called diagnostic momentum, whereas once a decision's been made and either a human or a device has said, okay, this is the diagnosis, that diagnosis gets perpetuated and propagated. If it is incorrect, it is often a lot harder to counteract. And I know this sounds completely mad, but it does happen a lot in clinical practice where you have multiple different teams and doctors seeing a patient, and they'll look at the chart and they'll have a diagnosis X, Y, Z, medication A, B, C. And because it's there and it's been made by someone else or made by a machine, it's a lot less likely to be questioned. And so if a algorithm, is prone to an error, you have to understand that not only will there be biases with the operator that's immediately, working with that system, but also that error will be perpetuated amongst the care team and will be a lot harder to subsequently challenge.
Yeah, because it's a differential diagnosis and it's basically like a decision tree. And once you get 5 levels deep into the decision tree, and then you have to say, oh, actually, we made a mistake 4 levels ago, or there's a hypothesis 4 levels back that we should have tested, or we'd like to test in retrospect. It's kind of hard to roll back.
Yeah, and new information arises all the time. You know how you go into hospital and people ask you your patient history kind of 20 different times. A lot of that is actually because people tell different stories different times, and patients will forget things. I myself as a patient, I will forget things because you are unwell. And so, with a diagnosis that the system has made at a certain point may not subsequently be correct in the light of new information. And if that system doesn't have access to that information, there's a perfectly reasonable chance that it will be incorrect. I think that when we talk about, these image recognition software, I think that that's a slightly different situation where you're using it in a very, very isolated context, and you're only asking it to do a very narrow task, which is just to look at that particular image. Additional context will be provided, and actions will be provided by the physician. You're not asking it to take a more holistic view.
Okay, so there are environments that have highly routine things within them, like shipping yards and warehouses that have become heavily automated with success. And, I think of a hospital as a place where there's a lot of routine behavior, and certainly there's non-routine behavior where you have lots of edge cases and you really want a human in the loop, but there is certainly a lot of it that could be automated. Do you have any perspective for where we're going to be in terms of automation in 5 or 10 years? Are the bedpans going to be cleaned robotically, or what's going to change?
I think when you look at the automation of healthcare, I think what's really interesting is to think about the information. So machine learning, itself is one task, but things either side of that. So you need to look at things like reimbursement, the speed at which guidelines and practice changes, and all of the kind of ecosystem around the technology, because healthcare is incredibly perverse in terms of the way that it's paid for. I'm from the UK, and it's pretty perverse there, but it's a little simpler than over here. I'm just learning about your system. But one of the main things that I think will prevent that happening is that it may not necessarily be something that is paid for. So one of the challenges that we talked about is just data entry. Doctors do a hell of a lot of data entry, and they spend an awful amount of time kind of coding, and actually that's not an efficient and productive way to use their time. However, because the way we pay for healthcare doesn't value the way doctors spend their time, sometimes those things aren't likely to actually find a way in. The way I describe it is that healthcare is a bit like a kind of a mountain through which there are grooves through which money flows, like water flows downstream, right? And you have to find those grooves through which water flows. And so current models of healthcare pay based on activity. And so if it is something that you can easily bill for, and that often means things that are very technical. So anesthesiologists, for example, can bill for lots of things because they do things like put lumbar punctures in and put lines in, whereas a psychiatrist or a neurologist can't bill for so many things because there's not so many kind of active procedures that they can do. And so what we're trying to move towards is a payment based on outcomes. So billing for the fact that the patient is actually feeling better, rather than just billing for what we did to them, billing for the outcome that they experience, which seems kind of crazy that we don't actually pay for patient outcomes. We only pay for just activities. But I think as we move towards paying for patient outcomes, that will probably mean that technologies that improve efficiency and quality of care will be more likely to be reimbursed. So the patient outcomes are measured in two different ways. You've got kind of clinical and social outcomes, and you've got psychological outcomes and patient experience measures. So this is all about, okay, fine, I've had a knee replacement, but am I feeling, back to normal? Am I able to look after my kids? Did I have a okay time in the hospital? And the things that affect that may be things like, improving the efficiency, automating some of what doctors do so they can spend more time speaking to the patient, rather than documenting, and can communicate the patient's care better and give them a better experience. Whereas currently, communicating to the patient, giving them a better experience and explaining things is not something that you can easily bill for. And so it just depends on the payment models. And I think that any company that is trying to bring machine learning into healthcare, the main thing you have to understand is how things are paid for, because otherwise you'll never get the product in. And that's one thing I think is quite interesting is when you spoken to a few machine learning companies recently who are looking at using natural language processing on patient records. And the kind of negative side of following the money is that often these companies tend to provide all of this amazing analytics and data extraction on these patient records for insurance companies, but not actually for frontline clinical practice. So I think that following the money is, you need to do it, but equally, I'm not sure it often necessarily leads to providing the benefit of that technology to the people who actually need it, which is the clinicians.
Cloudflare runs 10% of the internet, boosting the performance and security of millions of websites. Many of you probably already use Cloudflare on your sites, but we're not talking about using Cloudflare today. We're talking about building on top of it. If you're a developer, you can build apps which can be installed by the millions of sites which rely on Cloudflare. You can even sell your apps. They can make you money every month. Your users can log in or register to your service inside your app. They can get a real-time preview of your tool live on their site, and they can start paying you monthly, all from within Cloudflare apps. They can go from never having heard of you or your service to having it installed on their site and paying you in seconds. Visit cloudflare.com/sedaily to watch how you can build and deploy an app in less than 3 minutes. That's cloudflare.com/sedaily. Thank you to Cloudflare for being a new sponsor of Software Engineering Daily. Well, it's also hard to just scale the mountain of selling a product or presenting a solution, even a beta test of a solution, into the medical industry, because you have to get buy-in from a lot of people who are they're already overwhelmed with the amount of medical work that they're doing. They're not necessarily technologists, they're nurses or doctors or surgeons. And I follow Atul Gawande, and he writes about this with, this was like the whole, he wrote a book on the checklist manifesto about just trying to get clinical practitioners to use a checklist. Like, he's like, okay, we showed that if you use a checklist and say these are the things to do during surgery, make sure you count the number of sponges on the operating table before and after an operation to make sure you don't leave a sponge in somebody's brain. You want to have a checklist, and pilots have checklists, and blah, 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 blah. And even just the technology of introducing a checklist was so reviled, and there was so much outcry to a lot of the people he talked to. It took a while for him to evangelize it. So for the people who have been successful at scaling that mountain of understanding the medical environment and actually successfully bringing a new product into, or new service or new ideology into clinical environments, what do they do right, or what exactly is the approach? And by the way, real quick, I just a separate anecdote I think is worth pointing out is this company Oscar, which is doing the health insurance, basically they built a health insurance company, but their realization was that they needed to build a full stack of health stuff because the pre-existing industry was so entrenched, they wouldn't be able to experiment and do interesting things and innovate. So they're like, okay, well, not only do we need to build an insurance company, we need to build clinics, we need to recruit doctors, we need to get everything, the full stack of healthcare, because we just simply cannot integrate with the pre-existing system.
I think that's very funny. Ginger as well, Ginger.io did that. I think they initially tried to bring in a technology that was, predicting depression and relapse and using smartphone sensor data. Subsequently found that the mental health systems just were not, able to cope with that. I mean, it was well beyond their abilities. So they've built the full stack and they have their own psychiatrists. And so I think that, if I knew the answer to that question, I would not be here right now. I don't know what I'd be doing, but I think that's the answer that many people are looking for. I think that the first thing it begins with is clinical evidence. And, as Atul Gawande mentioned, he provided evidence for it first, and then there was the challenge of implementation. And I think that many people try to do it first without evidence. And doctors are very black and white about things, where they feel like if there's data, then that will, mean that we can, that's highly motivating for them to make the change. However, it's obviously not the answer, I'd say. It's like laying the foundations. The next step, I think there are some people in the UK, there's one particular company that was very successful in getting their product into different hospitals. And one quick thing about the UK is that the NHS is not as like a single market. You don't just get your product into the NHS and then it's in the NHS. You do have to go hospital to hospital, and they all tend to be quite different. So he went hospital to hospital. There's a company called Doctor, which is basically, it's very simple appointment scheduling software, which sends text messages to patients when their appointment time and allows them to cancel. And very, very simple, but much needed. One of the things that he did very successfully is in each institution, he would spend a lot of time understanding, the layout of the land of who was who, and not only who was who in terms of their kind of roles and power, but who was who in terms of their roles and motivations and desires. So what he found was that actually going necessarily to like the top level person who you think should make the decision is not always the way you get in. Actually, he found a kind of middle level manager who was really passionate about digital health, who wanted in her career to make her next move into digital health. And she was his kind of champion. And so what they did was they set up a very, very small pilot and gathered evidence and data, and in a very tiny part of the system. And then they presented that to the wider group. And he just kind of followed along in her footsteps, and she brought him into the hospital. It took a year or two, but they got in. I think that is the challenge as well, is that like the timelines on which this happens are not startup timelines. They are, startups, are born and die in those timelines. So I think data and evidence, and then really understanding the motivations and the drivers of the people that you're trying to work with, and not necessarily assuming that roles have all the power.
That timeline of innovation, is that changing at all as the current generation of doctors rotates out and younger people rotate in? I
don't know, and I would probably, if I were going to take a guess, I'd say no, because it takes a long time to train in medicine. It is a very risky environment, and it's a little bit like, one of the things I used to liken it to is a little bit like you learn Spanish and you go to Spain to work in Spanish, and you don't want someone changing the language while you're there too much, right? Because that's going to screw up your ability to work. And so you learn medicine, you learn the language, it takes a long time to learn it, and then you get to a point where you can practice it, and a huge changes to practice, unless, it can be very kind of disconcerting and can cause a lot of anxiety. And I think that's probably where this, where resistance comes from, is I'm dealing with someone who's critically ill. I need to be in control of the situation and let things in and let things out. And I think equally, the other bit of resistance as well comes from autonomy. So that's another factor I don't think will change with the new breed, younger physicians coming in, is that you often go into medicine because you like a sense of independence and autonomy, which is being eroded by protocols and guidelines. But, that sense of autonomy can be threatened by checklists and by technology, because it takes the power away from the doctor to say, well, actually, I'm the expert and this is what I think. So I think that you have to really tread carefully with the way you speak to doctors about these things. And I think that a lot of radiology companies, these machine learning and radiology companies, have realized that and, have messaged around, saying, radiologists, this is to help augment your practice. And we will provide you with a user interface that the system highlights where you should be looking, rather than just saying, we'll do it. And I think that, you have to accept that doctors are kind of the gatekeepers, because they do need to be, because they're dealing with people's lives. It's a unique system.
I'd like to talk a little bit about the company that you're working at and the science the products that you're developing. I think it could be an interesting case study up against the topics we've already discussed. So you work at KariusDX. What is KariusDX doing?
Yeah, so it was spun out of Stanford, a research group led by Steve Quake, who was one of the pioneers of a technology that uses cell-free DNA. Basically what we do is we take blood samples from patients who are often inpatients, who are sick with an infection. We send the plasma and we spin it down and we extract the cell-free DNA. Now, cell-free DNA is basically in the blood, you have lots of tiny, tiny fragments of DNA, RNA, microRNA floating around. There's 99.99% of it, I don't know the exact number, is your own DNA, but a very, very, very small fragment is microbial DNA. And particularly if you have an infection, that's obviously a greater proportion. So we separate out the human and the microbial cell-free DNA, and we then sequence it. So we use Illumina next-generation sequencing, and we then have a database of 15,000 reference genomes, which are curated, cleaned up from publicly available ones. And then we have a kind of a clinical database of 1250, which are curated for clinical relevance. And we align the reads that we find from sequencing with the database of 1250 microorganisms. And we're able to report on the presence or absence of any of those 1250. So what it does is it allows us to do things like see very deep-seated infections that other tests can't detect, because the other tests, there just isn't the presence of, other tests rely on presence of whole microorganisms in the blood. We just need tiny fragments. Or other deep-seated infections might be deep abscesses, they might be brain infections. It also allows us to detect bugs that can't be detected by other tests because they don't grow. So other tests rely on the growth of an organism to diagnose it, whereas we don't. And so we're very good at detecting things like fungi, invasive fungal infections, things like that. And so our range is the broadest that there is on the market today, and it covers a lot of organisms that other tests can't detect. Yeah, it's a very exciting new technology, and we are battling the bringing a diagnostic into healthcare fight as well. So.
The fungal topic I find interesting. I think I read something recently that was like, oh gosh, I think it was like connecting Alzheimer's to fungal stuff or something like that. But it was, I think one of the thrusts of, I probably just read the abstract, but I think one of the thrusts of it was like, fungal problems could be causing like a lot more than we realize. Is that consistent with when you're talking to people on the cutting edge? Are fungal issues sort of like a black box?
Yeah, I think that, we tend to deal with fungal infections with people who are immune compromised. So
right.
Our core product deals with those kind of infections where you have a fungus that would not normally, we don't think would normally cause a problem in a healthy human. But when someone's immune compromised from cancer treatment or from HIV, for example, then they wreak havoc. I think your question is really interesting. So we have a department called KariusDX, which is our kind of moonshot department. And basically that's where we conduct those kind of studies. So we are actually investigating a few really exciting topics like the pathogenicity of microorganisms in Alzheimer's disease. So whether or not there is a link between some kind of infection and Alzheimer's. We don't have a hypothesis as to what that might be. Any one of the 1250 on our list, we're kind of agnostic at the moment. It's just exploratory. And the other study we're looking at is preterm birth. So whether or not you can detect presence of an infection in women who subsequently have preterm labor, because that's often considered to be a cause of preterm labor is a uterine infection.
I sell podcast ads, and podcast ads are a weird commodity. Many of my potential customers are not actively looking for podcast ads, so I have to reach out to them with a cold email. This cold email process is what lots of people go through, whether they're marketing a software product, a newsletter, or an online course. I know there are a lot of people who are listening to this who are building some kind of new software product, and they're trying to figure out how to sell it. If you're building your own business, you have to learn to sell, and if you're going to sell, you have to learn to prospect. Prospecting is the process of gathering email addresses and sending messages to potential customers. Prospect.io is my favorite tool for prospecting. You can find email addresses of people at any company. You can find email addresses of users on LinkedIn. After you find those emails, you can use Prospect.io to manage your prospects and to send emails. You can see when somebody opens your prospecting email, and you can stop sending those emails when they have signaled that they're not interested. If you're building a product, you have to find customers to sell to. How do you find customers? By prospecting. I've tried a ton of prospecting tools. Prospect.io is my favorite. Prospect.io is offering Software Engineering Daily listeners 20% off your first 2 months. Just mention SE Daily to Prospect.io support after you sign up. And if you're selling something, try out Prospect.io. I hope you enjoy it. You must have seen this video of I saw this on Planet Earth a long time ago, but the ant where it gets the fungus in its brain and then it climbs to the top of the plant and then
Yeah.
the ant dies, and then the fungus grows in the sunlight. It's disgusting. It's just this horrifying feature of nature where you have this fungus that just takes over your brain. And then there was a video game called The Last of Us that kind of took this to another level. But it's kind of terrifying, and I don't think there's been much research that countervails the idea that there could be fungus everywhere that's controlling our brain, right?
Yeah, I think that's a really interesting phenomenon, isn't it? And I think there's another one with a rat, which and I don't know if it's a fungus, but and it means the rat will put itself in the path of a cat.
Yes.
And that's it. It's toxo. And there is actually, it's very dubious and kind of much debated evidence that there may be a link between toxoplasmosis and some forms of psychosis and schizophrenia. But again, it's very kind of, it's not really established yet. And then there's there's some really interesting research done by a professor at University of York called John Cryan, who looks at the influence of the microbiome on mental health. Mm-hmm. And he found an association between, he gave different mice bred to have different degrees of what you call behavioral despair. So you can breed mice and it's a trait used in the studies to assess the efficacy of Prozac. So you have this mouse that has high levels of behavioral despair, kind of behavioral depression, and a mouse that is, the happy mouse. And he showed that you could do a fecal transplant from the depressed mouse to the happy mouse, and you would translate that behavior over to this happy mouse. And that if you then cut the vagus nerve, which is a nerve that innervates the gut, comes up through the neck, if you cut the vagus nerve, you actually remove the effect. So that was pretty interesting, because we know from kind of just even language that the mind can affect the gut, in that, when you're nervous, your stomach starts to feel weird, and butterflies in your stomach. If you're in love with someone, you can feel it. There's all kinds of emotions that are transmitted to the gut, and the gut has the largest number of neurons second to the brain. But we don't have much evidence to say what happens when you have a gut pathology to the brain. And so I think there was some, and this is where I'm getting hesitant, but there's some evidence around Alzheimer's in the gut. Anyway, I'll leave that because I can't remember it. Yeah, John Cryan, really, really interesting research on the microbiome.
So what about pandemics and epidemics? I guess both questions are, how at risk is our population to a pandemic or an epidemic today, natural or man-made? And what kinds of diagnostic tools do you have within Karius that help identify that or predict it, or what's the product line? How does it reflect the probability of pandemic or epidemic?
Yeah, so I think that it all depends on how widespread the use is. I think what's exciting about our product is that it's inherently digital. And so, with greater use, you can start to map out the presence of different pathogens across different locations. So we are across 20 different organizations in the US at the moment, and, can map out what microorganisms are present at what locations in that particular patient population. We don't have enough data at the moment to make any interesting inferences from it, but in the future that would be something that we may be able to start to detect early on patterns at evolving sites. For example, you could start to see the emergence, increased incidence of MRSA or C. difficile at a certain hospital over another hospital, and potentially with ward by ward. In terms of other outbreaks, so I think the exciting thing about what we can do is that we have a very rapid turnaround time. So, within one day, we can provide a result on any of the 1250 organisms, which for many organisms is incredibly fast. For some, there are faster diagnostics, but only for a few of those. So, for example, there is a current outbreak occurring of something called Mycobacterium chimera, which is a bug normally found naturally just in kind of environmental water and soil, but it was contaminating some of these devices used in cardiac surgery, so they're devices that they cool and they kind of keep the blood warm. They're called a heater cooler device. And so when you do heart surgery, you take the blood out of the body and you pump it through this device. And this device is found to be contaminated at the source with this bug. And so anyone who's had heart surgery in the last 5 years, and that could be just a valve, it could be bypass, is at risk of having an invasive Mycobacterium chimera infection. The mortality, so the time at which you develop it can be months to 3 years after the surgery, 3 or 4 years after surgery, but the mortality is around 40% if you develop it. But the bug takes like 4 to 6 weeks to grow in traditional methods. And so we can detect it within one day. And I think that's been really, really exciting. So we've been working with lots of hospitals around those cases, and being able to diagnose them early means that, you can then provide the correct antibiotics to for that patient, in the appropriate time frame. So yeah, and I think there's so many different potential opportunities. It's just about widespread use as much as we can. So
in the catastrophe of antibiotic resistance, where are we with that? Is that still just terrifyingly lack of progress, or what's going on?
Yeah. It's still a major issue. It's still a major issue, and I think we will. We see more and more antibiotics become less useful. One of the main things really is getting a diagnosis early, identifying what it is before you leave that patient on broad antibiotics for days and days and days is the most important thing, narrowing down the treatment. So yeah, we are still, the world is still facing that potential disaster. Yeah.
So I know we're wrapping up on time, but just a few more questions. So this company Theranos, I was following this company pretty closely. This basically they were doing small vials of blood and trying to develop robust identification of problems with that. A lot of money went into it, and it just seems like it was just kind of a nice story. Probably there was some science there, but kind of mismanagement and conspiracy. Really good story if anybody wants to look it up. I think a movie's being made about it right now with Jennifer Lawrence. But did this cast a shadow over health tech at all, or do people basically regard that as isolated incident, totally crazy, cautionary tale, but this is not going to slow down investment?
I think for the health technology industry, which is decades and actually centuries old, we, particularly in the biotech space, it's an isolated incident. it is a company that, for some reason or other, did not think it necessary to provide evidence for its claims, which is something that, if you work in biotech particularly, is, bread and butter. And so, the ethos that Theranos held is not reflective of the wider industry in terms of the way the rest of the industry behaves. And, I think everyone was shaken by it, but I don't think more just because it brought into light an industry to, the wider world that normally was carrying on with its own business and being very effective and, performing very well. And now it's kind of shed a negative light to people who wouldn't normally know about biotech or normally understand it. They just know about Theranos. Mm-hmm. And I think that's the irritation, is that we've been continuing to do what we do for many, many years and performing very well and providing evidence. And, this company has kind of, cast a bad light on it. So I think that's the general attitude towards it. But yeah.
Okay, so last question. I did an interview a while ago about a cloud lab. I can't remember what the name of it was. I always forget the name of it. Transcriptic, that's what it was.
Yep.
So they have basically a thing where, it's essentially supposed to be like AWS for your biology. So if you're just in a dorm room and you want to get some kind of testing done, some sort of, you can just mail them a sample. They will do the work for you and send you back the results, and they do all kinds of stuff. It's basically your biology lab as a service, and they have a fully automated, like basically a robotic arm that interfaces with all these. It's pretty funny because it interfaces with all these old pieces of technology, and they reverse engineer the PCR machine and the like centrifuges and to be able to interface with this robotic arm and have a fully automated cloud laboratory. But so I look at this and I'm like, this seems like it could be really useful for up and coming scientists. Do you think this kind of stuff is, or maybe do you work with these kinds of companies? How is the accessibility of bio robots or cloud laboratories? I mean, there's also Emerald Cloud Laboratory, I think, that has a similar approach. So clearly there's a market developing. So how are these going to change things?
Yeah, I think they're really exciting. We know Transcriptic and visited them actually recently. So we have our own lab with our own processes, but certainly Transcriptic and there are other companies that can help you. I think the barrier to entry with biotech, I think, is still high, but is reducing, and that you can, outsource some of the lab processes that you want to run, experiments you want to run. You can get supply companies to build you gene chips, package them, and send them off to, as a product to consumers. So yeah, I think that's a really exciting space with the ability to reduce the costs, and you don't have to buy the capital equipment, and you're able to use one of these companies. Yeah, no, really exciting. We don't use them at the moment, but we definitely aware of them.
Indeed. Okay, well, Cosima, it's been great talking to you. Wide-ranging conversation. Enjoyed it a lot, and look forward to your future writings and whatever else Karius comes out with. I'm sure you got some interesting stuff in the lab.
Yes, indeed. Yeah, we do. Lots of really interesting data. So yeah, fantastic. Well, thank you very much, Jeff. It was a pleasure to be on your show, and I look forward to following it.
Cool. Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/SEDaily. That's symphono.com/SEDaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!